Dr. Ingraffea got his Ph.D. Civil Engineering, University of Colorado, his MS in Civil Engineering, Polytechnic Institute of New York, and a BS in Aerospace Engineering at Notre Dame. Since 1977, he has been a principal or co-principal investigator in over 35 million in R&D projects from NSF, NASA, Langley, Nichols Research. When I got these credentials, I was flabbergasted. So suffice it to say, he's really, really accomplished and really published. So I'm not going to go on. Thank you for coming.
Thank you for that kind introduction. Everybody hear me okay? As you probably read, I'm from New York, and you're wondering why I'm here. Two reasons. I was born and raised 50 miles south of here, so I'm one of you by citizenship. And development of Marcellus Shale is non-denominational. It crosses state lines. So my role in the increasingly focused talks tonight on environmental impact of Marcellus development is to build on what you just heard from the SRBC and get a little bit more specific about some very important aspects of the problem. And my thesis is that all the environmental impacts that you're going to hear about tonight are directly related to the total number of wells that you can expect to be drilled in Pennsylvania and New York. So the cumulative environmental impact, as you just heard, derives directly from the total number of wells. And you're probably wondering, if you haven't heard by now, how many wells are there going to be and over what period of time? So that's what I'm going to try to instruct you on, using numbers directly from the industry. So that total number of wells has to be viewed not only over space, how many per square mile, or how many in your backyard, but at what rate will they come online? As you just heard, the rate at which water withdrawals and waste fluid recycling is done is very important for the health of the Susquehanna River and the health of us. So I'll talk about the where, the spatial intensity, and that's driven by geology and by leasing. So the rock has a lot to do with it, but your decision-making process has an equal amount to do with it, and I'll explain why. The when is driven by Wall Street. How much capital can flow into this region to buy all the big rigs, all the equipment necessary, pay all the salaries to get the gas out of the ground. And it's also driven by the market. How much gas is needed, when, and where. So these are the questions I'm going to try to put numbers behind, and as usual, I'm going to warn you, the numbers are going to be big, sometimes incomprehensibly big. So my job is to try to make them make sense to you. So the numbers I'm going to cite, which are necessary to understand both the spatial intensity, how many wells, and the temporal intensity over what period of time, are industry numbers. The numbers I'm going to give you, you could calculate with a calculator if you had basic math. This is not advanced Cornell calculus. And these are not my numbers, they are industry numbers. They come out of a paper by your own Professor Terry Engelder, a colleague of mine from Penn State. Professor Engelder has done an exhaustive study and production prediction based on Marcellus coming out of the key 5 states. And I violated you. 42 counties, he estimates, are ultimately going to be producing gas in Pennsylvania. He then goes on further and makes what all engineers and scientists do, a model, a mathematical model based on the best available scientific data and the best available economic data. Because as I said before, the number of wells and the period of time under which they're going to be developed depends also on economics as well as geology. So this is data, for example, that shows if you have a well that's coming onto your property, this would allow you to calculate, not the landsman, not the gas company, you could calculate by way of a mathematical model the rate at which gas would come out of your well, say over 10 years. And it would also allow you to calculate the total amount of gas that comes out of your well. And then if you look at the newspaper every day, or go online and find out that yesterday gas sold for $3.71 per 1,000 cubic feet, knowing how many cubic feet came out yesterday, you could calculate what your royalty payment would be. Well, Professor Engelder doesn't care about your royalty payment. He's concerned about multiply the number of wells by the daily production, and that tells you the total amount of water that's going to be necessary to drill those wells. And it's also going to enable you to compute, as you just heard, an estimate of the amount of waste fluids that come back from each well. And that's where the environmental impact is. So here's the most important data for this evening. Wake up, take notes. This is the industry predicted ideal if they have infinite capital and all the leasing arrangements worked out just right. Over a 5-year period, this is what the industry is saying could happen in Pennsylvania. Ignore this column. Ignore this column. This is the 50% probability column. This is the most likely thing to happen. And it says that in Pennsylvania, over 5 years, with only 25 counties reporting in out of the 42, because they can't develop them all at the same time, Pennsylvania could produce 87 trillion cubic feet of gas. Over a 5-year period, Pennsylvania, if this model, if these predictions are correct, over a 5-year period, if all the capital was there to drill 160,000 wells, because if you read the fine print, it says over 20,000 square miles of Pennsylvania, if 70% of each square mile could be developed, and given the now industry standard of at least 8 wells per pad, 8 times 20,000 is 160,000, times 0.7 is about 130,000 wells. You know and I know that 130,000 wells aren't going to be produced, aren't going to be drilled and go into production in New York and Pennsylvania in 5 years. But this is the industry objective. They will never get there. It's impossible. You and I know that. So 21,000 pads, 168,000 wells over 5 years, multiplied by 70%, 130,000. If that were the case, and I emphasize, please don't misquote me. This is where somebody says he's disingenuous, he's being dishonest, he's making up numbers. As I said, every number I just showed you, you could calculate out based on that chart I just gave you. But read the chart, and it says, if there is no recycling, and clearly there is going to be some recycling, you heard about it from the previous speaker, but if there was no recycling, drilling 168,000 wells in Pennsylvania would require 924 billion gallons of fresh water. That's Chesapeake saying their average well in Pennsylvania is currently consuming 5.5 million gallons of fresh water. That would require 500 billion, that would produce about 500 billion gallons of contaminated fluids. I told you those are big numbers. 500 billion gallons fills Cayuga Lake twice. Anybody know where Cayuga Lake is? My backyard. Okay. And it would take 150 million one-way truck trips to get all those fluids to and from all the wells, if there were 168,000 wells, and there aren't going to be, and if there was no recycling, and there is. But I'm giving you industry numbers. So on the one hand, industry is saying, wow, we can produce almost 4 times the amount of gas consumed per year in the United States if we do this. But they can't. So I'm trying to be right down the middle. You can believe the extreme statements of the environmentalists, or you can believe the extreme statements of the gas companies, or you can believe your own common sense. Okay? So your common sense is that's not going to happen, because that can't happen, and if that happened, this would happen, and that would happen, so let's get realistic. Okay? Realistically, this is not what you're going to see in Pennsylvania. You've all seen this picture. This is Wyoming. That's 40-acre pad spacing. And be careful when you read things in the newspaper and hear things on the radio, people are constantly confusing terminology because they don't know any better. If all newspaper reporters had degrees in engineering, and if all politicians had degrees in engineering, and if all lawyers had degrees in engineering, the world would be a better place to live. But a spacing unit is not the same as well spacing, and it's not the same as pad spacing. So this is a 40-acre pad spacing. That's not happening in Pennsylvania or New York.